Students, in this video I'll start with the mechanical properties of elastic behavior. So see here, in axial tension. Axial tension means when you apply a load like this, the axis of this material this tension acts on the axis. The material is elongated. If you apply tension, the material will be elongated and there will be reduction of the cross section. Axial compression test, like see, this is axial tension test and this is axial compression, forces acting here. Here there may be a chance of material elongation. In compression test the material will shorten, so the increase of the cross section, so due to this there will be increase in the cross section. Here we are coming with Poisson's ratio, is the ratio of the lateral strain to the axial strain. It is sigma L by epsilon L over epsilon A. So Poisson's ratio is given as minus of epsilon L over epsilon A. So this Poisson's ratio is minus epsilon L by epsilon A. So now we're coming to a problem. We have a problem here that a rod made of aluminum alloy with a gauge length of 100 mm, diameter of 10 mm and yield strength of 150 megapascal was subjected to a tensile load of 5.85 kilonewton. If the gauge length was changed, when the tensile load was applied on a rod, obviously the change of length is increased, the material is elongated. The gauge length was changed to 100.1 mm and the diameter was changed to 9.9967 mm. So calculate the modulus of elasticity and Poisson's ratio. I'll try to explain this problem on the board, so let's catch in another video. Dear students, I am going to explain a problem in slide number 16 in your part 1 slide of unit 2. So if you go through this unit 2 part 1 presentation, there is a problem in slide number 16 which says that a rod made of aluminum alloy with a gauge length of 100 mm. I have written the problem in a short manner. I'll read it and I'll tell you. A rod made of aluminum alloy with a gauge length of 100 mm, diameter of 10 mm, like diameter of 10 mm and yield strength of 150 megapascal and tensile load of 5.85 kilonewton. If the gauge length was changed, to 100.1 mm and diameter is reduced to 9.9967 mm, calculate modulus of elasticity and Poisson's ratio. So we have gone through these formulas in the previous video, that which shows that we have formulas. I'll repeat them once. In your previous slides you can have these formulas. What are the formulas we required here? Stress is equal to force by area. Stress is defined as sigma is equal to force by area. Stress epsilon is equal to delta L by L, change in length by original length. Young's modulus or modulus of elasticity, capital E is equal to normal stress by normal strain. Poisson's ratio, Poisson's ratio is denoted by V. V is equal to minus of epsilon L by epsilon A, that is lateral strain over axial strain. So these are the four formulas which we are going to use in this problem. See, first thing, we have gauge length of 100 mm and diameter of 10 mm, yield strength of 150 megapascal, tensile load of 5.85 Newton. Load is nothing but, you can consider it as force. Area, you have to write like this. So first we will find out stress. Sigma is equal to force by area. So sigma is equal to, what is the force here? Force is in kilonewton, 5.85 kilonewton divided by area. Area means we have area, steel rod is can have like this. Steel rod is like this. The length of the steel rod is 100 mm. The diameter of the steel rod is 10 mm. So this area you can write it like as pi r square. Diameter is equal to 10, radius is equal to 10 by 2, that is 5 mm. Okay. See, I need some conversions here. I have to change this newtons into kilonewtons. I want to change this mm into meters. As you all know, converting kilonewton, 1000 Newton, like converting meter, 1 meter is equal to 100 centimeter, 1 centimeter is equal to 10 mm. So yeah, you want to convert this 10 mm into this, you can write like 1 mm is 1 into 10 power minus 3 meter. 1 into 10 power minus 3 meter. So sigma is equal to 5.85 into 10 cube Newton by pi 5 into 10 power minus 3 whole square in meter. So if you do this calculation, 5850 Newton divided by pi can write like 3.14 multiplied by pi square 25 into 10 power minus 6 meter. So you calculate this equation and you find out this answer. This answer can be 74.5 into 10 power 6 pascals. So 1 Newton per meter is equal to 1 Pascal. So you can write like this, 5850 Newton divided by pi r square. So once you solve this, you can get the answer 74.5 into 10 power 6 Pascal. So finally 1 megapascal is equal to 10 power 6 Pascal. So here we have 10 power 6 Pascal. So we are writing it as 74.5 megapascals. So here the finally you can write stress is 74.5 MPa. So I'm rubbing this, then we'll calculate the strain to delta L by L. So as the rod was subject to a tensile load which is like this, the tensile load acts in a axial direction. Tensile load acts in a axial direction. So the change in length might be like this. So we can consider the strain as strain epsilon A, axial strain, is equal to delta L by L. What is the changed length? Changed to gauge length of 100 minus 1. So change delta L means 100 minus 1 minus original length 100 over original length is 100. So if you solve this, you can get 0.001. So this is the axial strain, 0.001. So here what is the first thing we are supposed to determine? Modulus of elasticity. It is denoted by capital E. So I have a formula, capital E is equal to normal stress by normal strain. From the problem we have 74.5 MPa stress divided by 0.001 is value. So finally you get the value of 74.5 into 10 power 3, if you bring it to the numerator, MPa. Again 1 GPa is equal to 10 power 9 pascals. Already MPa is 1 MPa is 10 power 6 pascal. So already we have 10 power 6 pascal as a MPa. So we have added another 10,000. So we can write like, totally you can write it like GPa, gigapascals. So total the modulus of elasticity is 74.5 GPa. So this is calculation of modulus of elasticity. So you have determined this modulus of elasticity. Next one what we have to decide is Poisson's ratio. So Poisson's ratio we can determine by the formula Poisson's ratio is denoted by V, which gives you the equation minus of lateral strain by axial strain. So we know already this axial strain is 0.001. Now we have to determine this lateral strain. So the strain when the force applied in tension, in this it is axial direction, this is lateral direction. So here the lateral direction is in diameter. So to determine this lateral direction, we can have a equation delta D by D. What is the change in diameter? 9.9967 minus original diameter, 10 over original diameter. So if you solve this equation, you will get the value of 0.00033. So this is the value of lateral strain. So you know axial strain and you know lateral strain. So here we calculate Poisson's ratio V is equal to minus lateral strain 0.00033 over axial strain. Axial strain is 0.001. So if you solve this equation, finally you are getting this Poisson's ratio V as 0.33. So that is why we have calculated this modulus of elasticity is 74.5 GPa Poisson's ratio V, and this is E. Poisson's ratio V is 0.33. So I think this video will help you to solve this problem, so as you can understand in a better way. So the students who are not able to follow, not able to understand, can watch this, like you forward it, you rewind it, and moreover try to understand the problem. If you still face any problem or any difficulty to understand this, you can please meet me. Thank you.